Alright, this next topic is all about taking measurements and how we report those measurements. And what we're looking at is the number of significant figures, or the numbers that matter the most. Despite the fact that we have a very, very large value on top and a very small value on bottom, they both contain the same number of significant figures. Furthermore, both of these can be expressed so that they can be written with only 2 digits as a function of scientific notation. So when we're talking about significant figures, we're consisting of a certain number, a number of accurate digits, and in the scientific community we're also going to include plus 1, and that's specifically the last rounded digit. We're going to learn how to do that rounding process as part of this video. The big thing to remember is that the last digit is an accepted estimation. Alright, to determine the number of significant figures in our data, there are a series of rules. Now I'm going to run through these rules here with you and provide you with some of the examples over here on the right side as well. The rules aren't nearly as hard, and I'll show you a shortcut afterward, but it is important to kind of know the rules as we proceed. So first and foremost, all non-zeros are significant. 1 through 9 are all considered to be significant digits. So as you can tell from the number 123, all numbers are non-zeros and are automatically going to be considered significant. The next one, the one I like to refer to as the sandwich rule, refers to a zero that's trapped between 2 significant or non-zeros. Now, all non-zeros are automatically significant, and some zeros will be significant. When it's sandwiched, as is the 0 in this case here, we're going to have a 3, which is an automatic, and another 3, which is an automatic. And the meat in the middle, that 0 there, is going to be considered significant because it's keeping those 3's apart. I could furthermore take the number 7,005. And because 5 and because 7 are automatic, and the zeros here are sandwiched in between, we would say that this has 4 sig figs. The third rule is that a leading zero is never significant. So if we have 0.0 here, those are considered to be placeholders. We could rewrite that number 1.458 times 10 to the negative second power and remove those zeros and not lose any meaning whatsoever from our number. The last rule is that a trailing zero is only significant when it is to the right of the decimal point. So if I had the number 265,000, those zeros are placeholders, and I could rewrite it 2.65 times 10 to the fifth power. However, if those zeros are after a decimal point, they're adding significance or meaning to the measurement. 265 is a different number than 265.00. 265 is rounded to the ones place. 265.00 is rounded to the tenths place. The hundredths place. The shortcut that I'm going to give you is a rather clever one if you really give it some thought. On the west coast of the United States, we have the Pacific Ocean. On the east coast, we have the Atlantic Ocean. In between, we have our continental landmass. If you ask yourself the question, is the decimal point present or absent, you'll have your starting point. So take any number and place it in the center of the continental United States. For example, we might try and test that sandwich rule by placing the number 407 in the middle. Now, at first glance here, is the decimal point present or absent? In this case, it's absent. We don't see it. So then what we're going to do is we're going to fly in from the Atlantic Ocean. And we're going to fly until we hit our first non-zero, which is a 7. We're going to count that digit and everything afterward, and we come up with 3 significant figures. If we were to look back at the rules, we would see that the 4 and the 7 are automatics because they're non-zeros. That's rule number 1. And that 0 between the 4 and the 7 is significant because it's sandwiched between 2 significant values. If we were then to take this and redraw that P and A again and take another number, say we're to take 1.005 0.50. And we're going to analyze it the same way. Is the decimal point present or absent? Well, the decimal point is right here, so it's present. So we're going to fly in from the Pacific until we hit our first non-zero, and we'll count it and everything afterward. There are 5 sig figs in this value right here. Because there are 5 sig figs here, we have to go back and look at the rules. 1 and 5 are automatic. These 2 zeros are sandwiched. And this is a final 0 to the right. All are significant. We're going to learn about rounding now with significant figures, and we'll have to spend much more time with this in class. But the idea is, if the number to the immediate right is less than 5, we're going to round down. So for example, we might look at 501. If this is the digit we're rounding, we're going to look next door. 1 is not great enough to round it up, so if we were rounding to that tens place, we'd have the number 500. If the number to the immediate right is greater than 5, we're going to round up. So far, this sounds exactly like what we've been working with our entire lives. So again, if we're looking to that place, we look next door at the 6, it rounds it up, we have 510. Now where things start to differ is when we move away from less than and greater than, but we go to the exact equal. So for example, if the number to the immediate right is equal to 5 and is followed by any non-zero, we're going to round it up. So the instance I might give you there would be 500, I'm sorry, scratch that, 505.1. Now if we're rounding to this place right here, we know next door to the 5. 5 in our traditional, what we've been going with our whole lives, has told us to round up. But 5, when we're talking about significant figures, says look one more spot next door. As long as that next door is not a 0, this will round up to 510. If this were a 0, then we have our fourth rule. So the last rule says if the number to the immediate right is equal to 5 and is followed by a 0. So in the case here, we're looking at this right here. It is followed by an odd number. I'm sorry. What we do is we go back, we look at the original number. So we're rounding here, look at the 5, tells us nope, go one more spot. That is a 0. Now we go back to the number that's being rounded. In this case here, 0. Is 0 odd or even? Well, 0 is an even number. Because 0 is an even number, we are not going to round it up, and this is going to be the number 500. Much more practice with this in class tomorrow.